Good evening, everyone. The last class is discussion about concept of capacitance of a capacitor. What is the meaning of capacitor? What is the use of capacitor? What is the expression for? That means what is the unit of capacitor? What is the two parallel metal plates? The capacitance of a parallel plate capacitor without dielectric media. What is the equation? And what is the capacitance of a parallel plate capacitor with dielectric media? What is the meaning of parallel plate capacitor? What is the factors of capacitance of a parallel plate capacitor? These concepts are, it is a discussion about in the previous class. One more concept is that is also discussion about, that is what is the expression for energy stored in the capacitor. That is the energy stored in the capacitor is, that is the final equation is, that is U is equal to Q square by 2C. U is equal to Q square by 2C. That means by using a basic definition of how to derive in this equation, first to draw the capacitance. The capacitance is stored in the potential difference is V. The capacitance is consist of one is positive charges, one more is negative charges. It is connected to the battery. The capacitor is connected to the battery. The potential difference is V. That means by using a basic definition of a potential difference, the potential difference means that is a V is equal to Q by C, or by using a definition of capacitance of a capacitor, or the capacitance of a capacitor is defined as, that is the charge acting for unit potential difference, or the potential difference of each capacitor is V is equal to Q by C, where the charge is taken as, that is dq. The dq be the extra charge, the charge transferred in the capacitor. The potential difference V is given by, that is that means work done. What is the work done? The work done transferring a charge dq is given by V into dq. That means the dw is equal to V dq, means the small work done dw transferring a charge dq is given by dw is equal to V into dq. Substitute the value of V, therefore dw is equal to, that is Q by C into dq. That is the capacitance is a take outside, that means integrate this equation. That means what is the total work done? The integration, by using integrate both sides, that means the total work done. The total work done transferring a charge from the charge 0 to Q, 0 to final distance. That is the charge of the initial position is 0. The charge of a final position is Q. That means the integral of dw, that means, or the integral of that total work done means, that is a w is equal to integral of dq or dw work done. That is the from the charge 0 to Q. The distance is 0 to Q, or the total work done w is equal to the integral of 0 to Q. What is the dw? That is a Q by C into dq. Q by C into dq, or total work done is equal to 1 by C is take outside, the integral of 0 to Q, Q dq, or the total work done is equal to 1 by C. The integral of Q with respect to dq is, that is a Q square by 2. The 2 is the integral, that is the take outside 1 by 2C, or the upper limit is Q, the lower limit is 0. The small q is replaced by upper limit difference lower limit, that is a Q square minus 0, or therefore the total work done W is equal to Q square divided by 2C. Q square by 2C. The work done, the total work done W, it is stored in the potential energy U. That means W is equal to U. Therefore, finally U is equal to Q square by 2C, where U is that is called potential energy. That is a energy, not potential, that is a energy stored in the capacitor. Q is called charge, and C is a capacitance of a capacitor. This is the concept of, that is the energy stored in the capacitor. Energy stored in the capacitor. Then next concept is a combination of a capacitors. The combination of a capacitor. What is the meaning of capacitor? Capacitance. The capacitance means the charge of the each capacitor to each conductor to the potential difference of between the two conductors, that is called capacitance. It is a electronic device. The capacitance is a electronic device. It is the, what is the use of capacitor? It is the storage of charges. That means the capacitance means it is the charge of each conductor to the potential difference between the two conductors. That is, equation is C is equal to Q by V. The, what is the unit of capacitance of a capacitor? The standard unit of a capacitance is, that is a farad, F-A-R-D, farad. The symbol is F. The standard SI unit of the capacitance of a capacitor is farad. Next concept is, that is a combination of a capacitors. The combination of a capacitors means the group of capacitors. The group of a capacitors is called combination of a capacitor. The group of capacitors is called combination of a capacitor. There are two different types of combination of a capacitor. There are two different types. One is the combination, that is a series combination, that is the capacitance of the capacitors in series. The capacitors in series. And second one is the capacitors in parallel. There are two different combinations of capacitors of a capacitor. That is the combination of capacitors means, that is also called equivalent capacitor. That is also called equivalent capacitor. Equivalent capacitor and effective capacitor, both are same. Equivalent capacitor and effective capacitor. There are the combination of a capacitors is called combination of a, the group of capacitors is called combination of capacitors. It is classified into two different types: capacitors in series, capacitors in parallel. First one is capacitors in series. The series combination, that is a series combination means, that is the capacitor C. The capacitors, that is the one capacitor, first capacitor one, that is called C1. The one more capacitor is, that is C2. C1, C2 is the two capacitors are connected to the one end to other end. They are connected in series combination. It is connected between one end to another end, and that is such as the potential. It is connected, the two capacitors are connected to the series, and it is also connected to the battery. That is the battery potential difference. That is a positive and negative terminal. The capacitor C1, the capacitor C2, and it is a consist of positive charges, negative charges, positive charges and negative charges. It is a position of a first capacitor is A, the position of a second capacitor is B. Then the charge of a first capacitor is Q, the charge of the second capacitor is Q. The potential difference of a first capacitance is V1, the potential difference of a second capacitor is V2. The two capacitors are connected in series, and it is also connected to the battery. There is a potential difference is the battery. First, what is the meaning of capacitance of a series? See, in this diagram, C1, C2 is the two capacitors. That means group of capacitors. C1, C2 is the group of capacitors. It is said to be series. It is said to be series. It is connected between one end to another end. It is connected between one end to other end, and such that the potential difference is different. The potential difference across the combination is equal to the sum of the potential difference of the each capacitor. That means V is equal to V1 plus V2. That means the total potential must be is equal to sum of the potentials of each capacitor. That means the potential difference is different of each capacitor, and the charge Q, the charge is the charge of the first capacitor is Q, the charge of a second capacitor is Q. That is the both of the capacitors, the charge is same. The charge is same. That is called capacitors in series. That means the capacitors in series means if two capacitors are said to be series, it is connected between one end to another end such that the potential difference is different, the charge is same. The potential difference is different, the charge is same. That is called capacitors in series combination. That is, the capacitors are series. How to derive that means derive the expression for, derive the expression for, that means find the expression for, find the equivalent capacitance of a two capacitors. Derive, that means derive the expression for if two capacitors, derive the or find the effective capacitance of, effective or equivalent, both are same, effective capacitance of two capacitors. How to derive? That means the in series combination. That means derive the expression for the equivalent capacitance of a capacitor in series combination. That is the CS. Symbol is CS. C sufficient S. The C sufficient S means the capacitance of a capacitor in series combination. First, draw the two capacitors as the diagram is as it is same. The two capacitors, it is connected in, it is said to be connected, it is said to be series combination. It is connected to the two term ends, one into other end. The two group of capacitors is, it is connected to the battery. That is the diagram. Okay, now that is diagram. That is the combination of a capacitors. The combination of this capacitors must be equal to the single capacitance. That is called single capacitance. That is the equivalent capacitance. CS called equivalent capacitance. It is also connected to the battery. That is battery. Potential difference is V. The charge of a capacitance is Q. The charge of a capacitance Q. The CS is called capacitance in series, or the effective capacitance in series combination, or equivalent capacitance of a series combination. How to find the CS value? See, in this diagram, the diagram is as it is same. The diagram is the group of a capacitors. It is replaced by a single capacitance. That is called effective capacitance. That is called effective capacitance. That is also called equivalent capacitance. See, that is what is the explanation of in this diagram? Consider the figure shows the A and B are the two capacitors connected in series. The capacitors C1, C2 are placed in the positions A and B. It is connected in series combination, and the V1, V2 be the potential difference across a C1 and C2. The V is a potential difference applied across the combination of the capacitors. The Q be the charge of each capacitor is same. First, what is the total potential? By using a basic definition of capacitance. What is the basic definition of capacitance? The capacitance is equal to that is a charge acting for potential difference. In this diagram shows the total electric potential is equal to sum of the individual potentials of each capacitor. That is called equation number 1. That is V is equal to V1 plus V1. First find the V1 and V2 values. How to find? By using a basic definition of capacitance, that is C is equal to Q by V. What is the potential difference of each capacitor? That is V is equal to Q by C. The potential difference of a first capacitor is, the potential difference is V1. The charge is Q. What is the first capacitance? That is C1. And similarly, what is V2? V2 is equal to, see, the second capacitance. The potential difference is V2. the charge is Q and capacitance is C2, that is Q by C2. This values, the V1, V2 values is substitute equation number 1. The equation number 1 can be written as the total electrical potential. The total electric potential V is equal to V1 is called Q by C1 plus V2 is called Q by C2. Therefore, V is equal to, the Q is a common factor. Q is called common factor, that is take outside, that is 1 by C1 plus 1 by C2. That is called equation number 3. That is the equation number 3. And shows the diagram 2, the group of a capacitors, that is a C1, C2 is the number of capacitors, is replaced by a single capacitance, that is called effective capacitance. Effective capacitance. Effective capacitance. What is the effective capacitance? The number of capacitors is replaced by a single capacitance, that is called effective capacitance in series combination, that is called CS. By using a basic definition of capacitance in second diagram, this second diagram shows that is CS is equal to, charge is what? Charge is a Q, the potential difference is V, Q by V, or V is equal to Q by CS, that is called equation number 1, that is equation number 2, that is called equation number 3. That means the effective capacitance means the group of capacitors is replaced by a single capacitance, that is called effective capacitance. See the equation number 2 and 3, comparing the equations 2 and 3, we get the equation 2 and 3, the LHS side potential difference as it is same, that is the cancel. The RHS side is Q into 1 by C1 plus 1 by C2 is equal to, the equation number 3 RHS side is Q by CS. Q get cancelled, both sides get cancelled. Therefore, finally the 1 by CS is equal to 1 by C1 plus 1 by C2. This is the expression for the effective capacitance of two capacitors are connected in series. Therefore, or the one more equation is, or it is simplified this equation, that is 1 by CS is equal to C1 C2 is the LCM, cross multiply C2 C1, or CS is equal to C1 C2 divided by that is the C1 plus is there, cross multiplication, take LCM, C1 C2 is the LCM, C2 plus C1, or C1 by C2 is equal to C1 plus C2. This is the combination of two capacitors. The two capacitors are connected in series. The effective capacitance of a series combination is, that is 1 by CS is equal to 1 by C1 plus 1 by C2, or CS is equal to, one more equation, or CS is equal to C1 C2 divided by C1 plus C2. That means finally the conclusion of in this equation is, the reciprocal of a effective capacitance in series combination must be is equal to sum of the reciprocals of individual capacitors. This is the expression for, this is the concept of series combination. This concept is called series combination. Once again, listen, the series of capacitors in series. What is the series combination? That is, the series combination means if the capacitors are said to be series, it is connected between one into other end, such that the potential difference is different and the charge is the same. That is called series combination. First, to draw the two capacitors are connected in series, the charge same, the capacitors C1 C2, and between, that is acting at two different positions A and B. The potential difference is different. This is connected to the battery, and it is a combination of a capacitor series is replaced by a single capacitance, that is called CS. That is called effective capacitance in series combination. Then in this diagram one shows what is the total electric potential. The total potential means that is V is equal to sum of the individual potentials of each capacitor, that is V is equal to V1 plus V2. But what is the potential difference of first capacitor? Potential difference of a second capacitor. The potential difference of a first capacitor is the charge is Q, the potential difference, the capacitance is C1. Similarly, the potential difference of a second capacitor is V2 is equal to the charge is Q, the capacitor name is that is C2. The V1 V2 values is substitute equation number 1, that is Q by C1 plus Q by C2. The Q is a common factor, that is a take outside, 1 by C1 plus 1 by C2, that is called equation number 2. Equation number 2. And the group of capacitors is, it is replaced by a single capacitance, that is CS, that is also called effective capacitance. That is the effective capacitance is defined as CS is equal to Q by V. What is the potential difference of this diagram? That is Q is equal to Q by CS, that is called equation number 3. By comparing equation 2 and 3, the potential difference both sides is same, get cancelled. The RHS side is, that is a Q by 1 by C1 plus 1 by C2 is equal to Q by CS. Q get cancelled. Finally, we will get 1 by CS is equal to 1 by C1 plus 1 by C2. The conclusion of this equation is the reciprocal of the effective capacitance in series combination must be is equal to the sum of the reciprocal of a individual capacitors. Or the one more equation is or the CS is equal to C1 C2 divided by C1 plus C2. That is the one more concept is, if three capacitors are connected in series, what is the equation? That is 1 by CS is equal to C1 plus 1 by C2 1 by C3. If the three capacitors are connected in series combination, that is the C1, C2, C3 is the capacitance of a individual capacitors. CS is called effective capacitance in series combination. Or that is C1 by CS is equal to, simplify this equation, C1, C2, C3 is the LCM, that is C2, C3 plus C1, C3 plus C1, C2, or the CS is equal to, that is C1, C2, C3 divided by, therefore C2, C3 plus C1, C3 plus C1, C2. This equation is called if three capacitors are connected in series combination. If three capacitors are connected in series combination. Next, this is the concept of series combination. The second type is combination. That is a second type is capacitors in parallel. Capacitors in parallel. Capacitors in parallel. How to? What is the first of all the capacitors in series combination? First listen, that is the one capacitor. C1 is the first capacitor, and C2 is the one more capacitor, C2. What is the direction of the C1 and C2? It is parallel to each other. The C1 is the first capacitor, C2 is the second capacitor. That is the C1, C2 are connected in parallel direction. The two capacitors is also connected to the battery. There is a potential difference. Potential difference. That is the represent symbol is, there is a battery. One conductor is big, another conductor is small. Capacitor means the two conductors are parallel to equal length, equal shape. Okay, that is the potential difference is V, plus and minus battery. The first capacitance of A, it is acting at a position is A. The second capacitor is position of B. The charge is different. The first capacitance of a charge is Q1. The second capacitance of a charge is Q2. The potential difference is V. That means the potential difference is same. In parallel combination, what is the meaning of the capacitors in parallel? The capacitors are said to be parallel, to be connected in parallel suitable parallel, they are connected between two common points. That is, A is the one common point, B is the one more common point. It is a they are connected between the two common points such that the charge is a different, the potential difference is same of a each capacitor. The charge is a different of a each capacitor, the potential difference is same both of the capacitors. That is the definition of a capacitance in parallel combination. The capacitance in the capacitors in parallel means if is the two capacitors, the two or more capacitors are said to be parallel. They are connected between the two common terminals, two common points, such as the potential difference is same and charge of each capacitor is different. That is called capacitance in parallel. This is the group of the capacitors. How to find the effective capacitance? Effective capacitance or equivalent capacitance. Effective capacitor, that is called CP. The symbol is CP. The effective capacitor means the effective capacitors in parallel combination, that is symbol is CP, or equivalent capacitors in parallel combination, that is CP. That is the number of, first to draw the two capacitors are connected in parallel to each other. These two capacitors are connected to the battery. This is the combination of a capacitors. This combination of a capacitors is replaced by a single capacitance. That is a single capacitance, that is called CP. CP is called the effective capacitance in parallel direction. That is connected to the battery. It is connected to the battery. That is the positive battery means it is a connections between positive and negative signs. The capacitance is CP. The charge is Q. That means the effective capacitors in parallel combination means the group of capacitors are replaced by a single capacitance. The group of capacitors are replaced by a single capacitance, that is called capacitance in parallel. How to derive, how to find CP value? Consider the ABB explanation. First, what is the explanation? A and B be the two capacitors are connected in parallel. C1, C2 be the capacitance of A and B positions. Q1, Q2 be the two different charges of each capacitor. V is the potential difference across the both capacitors. That is, first to what is the total charge of this diagram? The total charge, net charge must be is equal to sum of the charges, that is Q1 plus Q2. That is called equation number 1. Q is equal to Q1 plus Q2 is the sum of the charges. The total charge must be is equal to sum of the charges of each capacitor. By using a basic definition of capacitance, that is the charge of each conductor to potential difference between conductor, or charge of a, what is the charge of each capacitor? Charge is equal to CV. First, what is the find the Q1? Q1 is the charge of a first capacitor. The charge of the first capacitor is the potential difference is same. The capacitor is C1. Q2, the charge of a second capacitor is Q2. The potential difference is same. The capacitor is C2. The Q1, Q2 values is substitute equation number 1. The equation number 1 can be written as Q is equal to CV1 plus VC1. Q is equal to VC1 plus VC2, or Q is equal to V is the common factor, C1 plus C2. That is called equation number 2. Then the group of a capacitors is replaced by a single capacitance, that is called effective capacitance. Effective capacitor, that is called CP. The effective capacitors in parallel combination is as it is same definition. Therefore, CP is equal to Q by V, or the charge of this capacitor is, that is Q is equal to CPV. That is called equation number 2. Equation number 3. That is comparing equation 2 and 3. Comparing equations 2 and 3. Comparing equation 2 and 3. The equation 2 LHS side is Q. The equation number 3 RHS side is also Q. Q, charge both sides can but both sides get cancelled. The RHS side is V C1 plus C2 is equal to equation number 3 CPV. Potential difference, both sides get cancelled. Therefore, finally Cp is equal to C1 plus C2. This is the expression for the capacitance of a capacitor. Expression for the capacitance of a capacitor. What? The capacitance of a capacitor or the effective capacitance of a parallel combination. The Cp is the effective capacitance of a parallel combination must be is equal to sum of the individual capacitors. That is the concept of what? Parallel combination. Okay, thank you. Continue to next class.